Dinah purchased 200 feet of fencing to make a rectangular play area for her dogs. The possible area A is given by the equation below, where W is the width of the play area. So they do the work for us, where they tell us what area as a function of W is going to be. Which of the following equivalent expressions displays as a constant or coefficient the value of the width for which the area is a maximum? So that's an interesting way that they phrased it, but they're saying that these are all equivalent expressions to this thing up here. And you could verify that they're equivalent expressions. We could take, for example, this first one right over here. This would be the same thing as negative, let's see, W minus 50 squared is W squared minus 2 times 50 times W, so minus 100W plus 2500. And then you have plus 2500 out here. Now this is going to be the same thing as negative W squared plus, I'm just distributing the negative sign, plus 100W minus 2500 plus 2500, which these two things cancel each other out, and you're left with this expression right over here. Negative W squared plus 100W. And this would be true for all of these. So these are all just algebraic manipulations of this original thing. Now, what they're asking us, or one way to think about it, is which of these show the maximum value? Which of these forms of the expression make it easy for us to find what the maximum value is going to be? Well, let's look at this first one. Let's think about how this expression works. If this part right over here, W minus 50 squared, that's always going to be non-negative, because if you take the square of something, it's going to be non-negative. But then if you then take the negative of it, it's going to be non-positive. It's going to be non-positive. So this part over here is going to be less than or equal to 0. And then you have plus 2500. So if you wanted to maximize this expression, which is the same thing as maximizing this expression because they're equivalent, you want this thing, you want to not subtract anything. So you want this part to be equal to 0. So how can this part be equal to 0? Well, the thing that you're squaring is equal to 0. And in order for the thing you're squaring to be equal to 0, W minus 50 needs to be equal to 0, or W needs to be equal to 50. So just looking at this expression, we're able to figure out, because all of these expressions are equivalent, and they're equivalent to this expression right over here. Just looking at this expression, we're able to figure out, look, this expression takes on a maximum value when W is equal to 50. And to their question, which of the following equivalent expression displays as a constant or coefficient the value of the width for which the area is maximum? We know that the value of the width for which the area is a maximum is 50. And this one, I guess, displays it. I've never seen a question phrased exactly like that, but it does display the number. And this is why this form is so valuable. You want to say, look, the area is going to have a maximum value when this part right over here is not taking anything away from the 2500. In fact, 2500 is going to be that maximum area. And when do we reach it? When this thing is 0. This thing is 0 when W minus 50 is equal to 0, or when W is equal to 50. So I would definitely pick this one here. These other forms of these expressions, and you can algebraically expand these, it'll come out to be the same thing as over here. And these don't help you so much. You can't make that same type of intuition about where the maximum value is. And this form of a quadratic, this is called vertex form. It makes it very easy to find the vertex, which is going to be the minimum or the maximum value of an expression, or of a function, I should say. Now there's other ways to come up with the 50. You could say, look, this thing right over here, it's a quadratic. It's got a negative coefficient on the quadratic term, or on the second degree term. So it's going to be a downward opening parabola. So it might look something like this, where if this is the a-axis, the area axis, and this right over here is the width axis, that's the width axis, you would know that this is going to be downward opening because it has this negative right over here. It's going to be a downward opening parabola. So it's going to look like this. And so we just need to find the vertex, or we need to find the W coordinate of the vertex there. And there's a couple of ways that you can find the W coordinate of the vertex. One, you could say that coordinate is going to be halfway in between the W values that make our function equal to 0. And so we could say, well, what makes this thing equal to 0? You could say, 100w minus w squared is equal to 0. You could factor out a w. So w times 100 minus w is equal to 0. Well, this is going to be equal to 0 when either w is equal to 0 or 100 minus w is equal to 0. So, or w is equal to 100. If w is equal to 100, this part over here is going to be equal to 0. The whole area is going to be equal to 0. So this right over here is 100. This one over here is 0. The maximum point then, the vertex, is going to be the w that's halfway in between these two, which is going to be 50. So that's another way to think about it. You could also use the formula for the x-coordinate of a vertex, negative b over 2a. If you had an expression in the form of a w squared plus bw plus c, then, and then we could say a is equal to, this is a lowercase here, then the vertex is going to be, the w coordinate, I should say, of the vertex is going to be negative b over 2a. And in this case, b is 100. It's the coefficient on the first degree term. So it's going to, if b is 100, negative b is negative 100. And a is this negative 1 that's in front of the w squared. It's the coefficient on the second degree term. This, they wrote it the other way around, where they have the first degree term and then the second degree. Here you have the second degree, then the first degree. But a is negative 1. 2 times a is negative 2. And then negative divided by a negative is a positive. 100 divided by 2 is 50. So any way you look at it, w equals 50 is when it hits the maximum value. And if you looked at these expressions, which of these involve 50 as a constant or coefficient? Well, I see a 50 right there. It's a little bit of a strange way of asking it, but there's a 50 there. It's being subtracted, but it does show up. None of these other ones that you have a 50 anywhere to be seen.